Answers to the most common protein questions, Part 1. Today we are going to talk about the basics of protein. By the end of the article, you should be able to understand protein and define it. Be able to pick the protein source that would benefit you the most. Know the recommended amount of protein to eat per day. Differentiate between plant protein and animal protein. Find out if it is necessary to combine plant foods together to get a complete protein. Find out if it's right to take protein powders or amino acid supplements, especially if you are doing exercises or play sports. Know how vegetarians get protein. We will start with knowing protein.
Proteins play countless roles throughout the biological world. Some transport nutrients throughout the body. Some help chemical reactions to happen at faster rates. Others build the structures that make up living things. Despite this wide range of functions, all proteins are made out of the same 21 building blocks, called amino acids. Amino acids are made of carbon, oxygen, nitrogen, and hydrogen atoms, and some contain sulfur atoms. Selenocysteine is the only standard amino acid that contains a selenium atom.
Fundamental to many of these common topics and problems is the belief that meat is protein itself and protein is meat. This belief comes from the fact that animal-based foods are protein. In many types of dairy products and meat, we can selectively remove the fat, however we are still left with recognizable dairy products and meat. We do this all the time, with lean cuts of meat, skim milk. However, if we selectively remove the protein from animal-based foods, we are left with nothing like the original. A non-protein steak, for example, would be a bucket of water, fat and a small number of vitamins and minerals. Who would eat that? In conclusion, for a food to be recognized as an animal-based food, it must have protein. Protein is the core element of animal-based foods. How much protein should one take? Early scientists like Carl Voigt (1831–1908), an outstanding German scientist, were staunch champions of protein. He found out that the men needed only 48.5 grams per day, however nonetheless he recommended a high 118 grams per day because of the cultural bias of the time. Protein equaled meat, and everyone aspired to have meat on her or his table, just as we want to have bigger homes and faster cars. He also figured you couldn't get too much of a good thing. He went on to mentor several well-known nutrition researchers of the early 1900s. Some of them are Max Rubner (1854–1932) and Wu Atwater (1844–1907). Both of them followed the advice of their teacher. Atwater organized the first nutrition laboratory at the United States Department of Agriculture, known as USDA. As a director of the USDA, he recommended at least 125 grams per day. A cultural bias had become firmly entrenched. If you are civilized, you eat plenty of protein. If you are rich, you eat meat. Lastly, if you are poor, you eat staple plant foods, like bread and potatoes. The lower classes were considered by some to be inept and lazy as a result of not eating enough meat or protein. Arrogance and elitism dominated much of the burgeoning field of nutrition in the 18th century. The whole concept that bigger is better, more civilized, permeated every thought about protein. Major Mackay, an outstanding English physician in the early 20th century, provided one of the more entertaining, but most unfortunate, moments in this history. Major Mackay was stationed in the English colony of India in 1912 to identify good fighting men in the Indian tribes. Mackay said that people who consumed less protein were of a poor physique, and only a cringing, effeminate disposition can be expected. What are good sources of protein? Introduction. First, before we can know which protein sources are right, we need to clear some information. Protein, alcohol, carbohydrate, and fat provide virtually all of the calories that we need to consume. Protein, carbohydrate and fat, as macronutrients, make up almost all the weight, mass, of food, aside from water, with the remaining small amount being the mineral micronutrients and vitamin. The amounts of these latter micronutrients needed for ideal health are tiny amounts, milligrams to micrograms. Protein, the most sacred of all nutrients in the world, is a vital component of our bodies, and there are thousands of different kinds. They work as hormones, enzymes, structural tissue, and transport molecules, all of which make life possible. Proteins are constructed as long chains of thousands of amino acids, of which there are 15 to 20 different types, depending on how they are counted. Proteins wear out on a regular basis and have to be replaced. This is achieved by consuming foods that have protein. When digested, these proteins give us a whole new supply of amino acid, which is building blocks to use in making new protein replacements for those that wore out. Different food proteins are said to be of varying quality, depending on how well they provide the needed amino acids used to replace our body proteins. The process of disassembling and reassembling the amino acids of proteins is like someone giving us a multicolored string of beads to replace an old string of beads that we lost. However, the colored beads on this string given to us are not in the same order and shape as the string we lost. We break the string and collect its beads. Then, we rebuild our new string so that the colored beads are in the same order and shape as our lost string. However, if we are short of red beads, for example, making our new string is going to be stopped or slowed down until we get more red beads. That is the same concept as in making new tissue proteins to match our old worn-out proteins. About 8 amino acids colored beads that are needed for making our tissue proteins must be provided by the food that we eat. They are called essential because our bodies cannot make them. If our string of beads, our food protein, lacks enough of even one of these 8 essential amino acids, then the synthesis of the new proteins will be stopped or slowed down. That is where the idea of protein quality comes into play. Food proteins of the highest quality are just those that provide, upon digestion, the right kinds and amounts of amino acids needed to efficiently synthesize our new tissue proteins. This is what the word quality really means. It is the ability of food proteins to provide the right kinds and amounts of amino acids to make our new proteins. This is when the idea of protein quality comes into light. Food proteins of the highest quality are just those that provide, upon digestion, the right types and amounts of amino acids needed to efficiently synthesize our new tissue proteins. This is what the word quality really means. The ability of food proteins to provide the right types and amounts of amino acids to make our new proteins. Good protein sources. Can you guess which food we might eat to most efficiently provide the building blocks for our replacement proteins? It is human flesh. Its protein has the right amount of the needed amino acids. However, our fellow men and women are not for dinner, so we get the next best one by eating other animals. The proteins of animals are very similar to our proteins because they usually have the correct amounts of the needed amino acids. These proteins can be used efficiently, therefore, are called high quality. Proteins. Among animal foods, the proteins of eggs and milk represent the top amino acid matches for our proteins and thus are treated as the highest quality proteins. While the lower quality proteins in the plant may be lacking in some of the essential amino acids, as a group they do have all of them. The concept of quality is the efficiency with which food proteins are used to give growth. This would be well and good if the greatest efficiency meant the highest health, but it doesn't, and that's why the terms efficiency and quality are misleading terms. Researchers are showing that low-quality plant protein, which allows for the slow but steady synthesis of new proteins, is the healthiest type of protein. Slow but steady usually wins the race. The quality of protein found in a specific food is determined by how fast animals would grow while using it. Foods from animals emerge with a very high protein efficiency ratio and value. The focus on efficiency of body growth, as if it were good health, encourages the consumption of protein with the highest quality. For example, any marketer will tell you that a product that is known as high quality instantly earns the trust of consumers. For well over 100 years, we have been captive to this misleading language and have often done the unfortunate thinking that more quality equals more health. The basis for this concept of protein quality wasn't known among the public, but its impact was and still is highly significant. People, for example, which used to use plant-based diet will often ask, even today, where do I get my protein from? As if plants don't have protein while they do. Even if it is known that plants have protein, there is still the concern about its poor quality. This has led people to think that they must meticulously combine proteins from different plant sources each meal so that they can mutually compensate for each other's amino acid deficits. However, this is overstating the case. We now know that the human body can derive all the essential amino acids from the natural variety of plant proteins that we encounter every day. When it doesn't require meticulously planning every meal or eating higher quantities of plant protein. Unfortunately, this enduring concept of protein quality has greatly obscured this information. See you again in part 2.